Okay, go ahead.
Hello, everybody. So today we'll be discussing about arrays, and these are the very basic data structures that we begin with. And I can speak for myself. I always took it very lightly with arrays, and I've got stumped so many times in the interviews with arrays, and especially with two-dimensional arrays, like when we are trying to navigate, walking through. So one of the problems that I did several times rotating the image, and I kept mixing it up in the interviews. So that's one of the problems I've picked today. And one thing, if anyone want to share who are recently interviewing and what kind of problems they're seeing before we start jumping into these questions. Anybody want to talk about their any observation, or what is the common problem these days, like interviewers are asking? Okay, so I'll just. So
So,
one thing when.
sorry to cut you. I recently came across a question on arrays. It's like an intersection of two arrays.
Okay, so do you want to talk about what was your approach?
Um, I mean, yeah, I went with brute force approach. Um, um, yeah,
Can you
I
please
went with
quickly
it was a
in
long
one?
back, but I couldn't remember. I think I went with the brute force. It was a long back actually.
Okay, so one thing when I'm preparing for it is couple of things that I kept in mind. One, that most of the problems that I'm coming across, either it can be categorized either how we having two pointers, one at the end, one in the beginning, and how we play around with that. Then the second approach was how we are, traversing the two-dimensional array. That was the second set of problems. And the third was how, when we are walking through the array, what are the values that we are keeping track of? And so with the first question that we'll look at it today, that's where, like in this question, why I picked this is because this is where we need to see, we have to keep track of the sum of the sum of subarray, and also if it's the maximum in the entire array. So when we read the question, how are we figuring it out, what we need to keep track of? So I'm going to go ahead and if everybody can look at the first question. It talks about we have to find a maximum sum in a subarray. So if we look at the example, the input, and this input, we have both positive and negative integers. And in this case, the maximum sum is 6 because we are calculating this. So it's a subarray, contiguous subarray, means that the elements that we are keeping track of, the sum of those elements, they're contiguous. It's not like the 4 here and the 4 in the end. It's not that, it's contiguous. So anyone to talk about like what approach we should be taking?
So one approach whenever I see subarray that I try to take is and the two, it is a contiguous subarray. I usually think of like the sliding window approach, right? So where you, because you have to keep track of the window, right? That window would be like the subarray that you want to find the sum of. So that's one approach that I usually start thinking about whenever I see like subarray and contiguous subarray.
We can do this
So
with
basically,
cadence Alahaldun too.
Oh, Kaden?
Yeah.
Oh, okay.
But before that, let's wrap up that thing. Why sliding window couldn't work here?
Oh, why sliding wouldn't work here?
Or it may work, I don't know. Or even I have seen like when there are questions like this, a pre-map could also help, where you keep on taking uh, consecutive number sum and storing in a map. But I have seen like when the target is moving, like
Mhm,
it says larger sum,
mhm.
then it becomes tricky because we are not achieving some in a finite target. We are trying chasing a moving target. So there I have seen like sliding window or other algorithms could not work. That's my
Mm.
take on this.
I think it will work, but order
Yeah.
of n square it will be. Like first you take such contiguous and then find the maximum out of it. Yeah,
Oh,
but Kadanes do it in order of n.
I think sliding window also would do it in order of n, right? Because
Usually, yeah, yeah, go ahead.
uh, it would be
But the
kind
target is moving. Like we want to find the largest sum.
Mm-hmm, mm-hmm.
So what window should I take? I need to expand or
Yeah.
collapse the window
So
at every point.
yeah, you start with the first number,
Mm-hmm.
subtract the sum there, and
Mm-hmm.
then you keep expanding the window
Mm-hmm.
until you find a sum which is greater than the maximum sum you have so far.
So now, if I understand you correctly, you are suggesting that I have 2 point
Mm-hmm.
indexes, say int start,
Mm-hmm.
which is 0, and then have another one int,
Yeah.
say end
Right.
for that, and which also starts with 0.
Right.
So right now, okay, in our first input,
Mm-hmm.
first we are so first we will have is
Yeah,
we are
if you
looking
have the
at that.
max sum as int underscore min, initialize it as. Oh yeah, yeah. So go ahead. Yeah, yeah. You're looking into the array. Yeah. Right.
Okay, so yeah, you want to keep track of int max sum,
Mm-hmm.
and so this max sum is
I would do it in minimum because you have negative numbers here, right? So,
that's correct. Um, do you think it'll be easier if you take control and you start?
yeah, I can do that. Do you want to give me control?
Okay, I
Naga, you can also ask for a control or claim.
how
Uh,
do I give you the control?
yeah, yeah. I have a request remote control.
Okay.
You need to open the system preference and I think give
Yep.
it.
Give me one. And, sorry, I think
Yeah,
I
I
lost
mean,
that.
if if you guys already think that it will not work and you want to move on, that's also fine. Actually, I feel like it would work, but
See, the
Yeah, I
other
think it
algorithm which
worked.
somebody told
Mhm.
is actually the solution for that. But like you said,
Admit,
intuition, how we develop intuition, that
yep,
is important.
yeah, yeah, yeah.
Okay.
If
I think
that's what you want to do, like, yeah, we can go over the approach.
I did give you. See,
Uh, you're controlling, I don't know. It says you are controlling, but when I type, it doesn't allow it. View options, view my keyboard view.
Give me 1 second, I think.
Oh yeah.
Okay.
I select.
Yep.
Oh, no. Oh yeah. Good. I got it. Okay. Let me take this example and go about that. Okay. It's a bit slow actually. There is a delay, I think. Okay. So okay. So I start here with both my pointers, and the maximum sum I have would be like -2, right? And then I sorry, yes, I think it's somehow it is slow. Okay, and then I move to 1. I try to expand the window. I move to 1, and then I see like the maximum sum now is -1, which is greater than my earlier maximum sum, which is -2. So then I update I update it, and then I go again, try to expand it to -3, right? And -3 now, my maximum sum so far was -1, and the total sum here is like -3, -2, 1, which would be like -4, right? So that is not my max, that is actually less than my maximum sum. So I start to contract from this, I start to compress the window from the start. So I'll compress it from the start. So now my window would be like just with these two numbers. And I calculate to see like what it is. I do that until my sum is, my maximum sum is either greater, until I find something is greater. If it is less, I try to find this small windows to find it, and then I start to expand this window. Typical dynamic sliding window problem.
Okay, now the sum is
when you write pointer at -3, what is the max value from?
When I have the right pointer at -3.
Yeah.
So every time there is a max value. So when we start with the problem, the max is the total max is, if suppose like int underscore min, and when I started with the first initial value, the max became -2, right? Because so far the max is int minimum, and my window was just at -2. So when I started this one, right? When I started this one, my window is only -2 and my max was int minimum. So because my window sum is greater than max, I changed it. And now I have expanded like this, and now my local sum is -1. What we are trying to find is a window, right? Sub window. So in local, I'm calculating the window I am at and the sum of that window. So my local sum now is -1. And every time I get the sum of a local sum, I try to compare it with the maximum and see like if I have to update the maximum. So in
Yeah.
this case, I see that max is less than my local sum. So far my best is -1,
Mm-hmm.
right? Now I expand here.
But
Uh,
Naga, one thing is, in case of just like having two element like -2 and 1, so 1 itself is the biggest, right here. Like if you don't do any sum, so out of -2 and 1, 1 itself is the biggest element. We have to consider that scenario as well, right?
right.
Yeah,
Yeah. So
you're right. You're right. We
one more
expanded
condition.
to
We have to check
one.
the whichever element we are considering from the right pointer. If that itself is greater than the yeah,
Point sum.
then we assign that as a max sum. Like 1 itself
And,
will be a max.
and from there, your window can start again.
Uh,
So
okay.
basically, that is a trick here, how to restart your window.
Yeah, I think so because
So
yeah,
I got a -1 when I did this one.
yeah.
So
But your second element itself is 1,
second element.
which
So
is
the
greater than the previous max and the current max, what is coming right now.
right.
So what?
So when I compress from the starting would have to change here.
So what Sumit is telling is, so here you got -1 is your local,
Mm-hmm.
and your max is also -1, but 1 itself is a better window, just taking 1.
So
Right.
in that case, both the pointers make it to 1, both left and right. The moment you find that 1, I mean the maximum you have seen is 1, and from there new subarray will start.
Yeah, and that's what, like, we can ditch the previous window
Yeah,
and see a new window.
exactly. You
Uh,
move this your left pointer to also 1 only.
So
but
reset
what
your
condition would we move it, right?
yeah, you can reset your left and right to same position.
But on what condition? Like,
On
Like if current element itself
mhm.
is greater than your current sum and maximum
current,
sum.
yeah. And I think we have to check for negative as well. I'm not sure because it may happen that the current sum or the current element itself is greater,
that
but together it can make a bigger max sum, right? So
Mhm.
we cannot ignore that fact also. Like 1 is bigger in this case than the sum, but the previous sum, but the sum itself, the previous sum could add up to the new element as well, right?
it will be covered in this only.
It will be
In
covered
this,
because this is
Hmm.
Yeah.
addition, or
Okay.
if it is a multiplication, then it could be different
yeah.
because your previous negative and current negative can make a bigger number, but here it might not impact.
The condition for moving the left pointer would be like if you take the previous sum and when you add your current element, the
Mhm.
sum of that and the current element, whichever is maximum, like now your current element is 1 and when you added 1 to your previous, it was -1, right?
Right.
So whenever you see that your current index element is greater than your sum so far, then you just
Mhm.
move your left pointer to the
Okay.
place where right pointer is.
So
Okay.
and
So let's consider that whenever the current pointer is greater than the max so far,
Uh,
then we use
not max, the current sum, running sum.
the current
Running sum.
okay. So if that's the case, then we had the current sum as -1 and the current element is 1.
One.
So max is 1.
Yeah, which is a better window.
Yeah, which is a better window, that's for sure. In this case, it worked. So let's see how that goes for the next one.
Now your local is also 1.
Local was -1 anyway, right? Local. Oh yeah.
So
Now we
basically,
changed it. Okay, now we change. Yeah, that's right. Okay. Now I compressed it, and then my local is 1. So then I start expanding to the right again.
mhm.
So this -3. Now the local is -2, and
Mhm.
my current is actually less, and local is also less.
Yeah,
So
that will
I still
minus.
continue to. uh, continue to
Your
4.
local becomes -2 there.
Yeah. The pointer is slow, so I was trying to avoid that.
Okay.
I don't know. Is it always like that, or is it like that today?
No,
Don't
maybe because of the less bandwidth. Otherwise, maybe the net connection, your and hers.
Oh, okay. Possible. So it was -2. Now with 4, it has become 5 minus 3 as 2. And but my current number is actually
better.
greater than, so I would update the maximum sum to 4, right? That's what we were thinking, right?
Yeah.
Whenever
Yeah.
the current is more.
Exactly.
Okay, that's good. 4. And now we start compressing from the start.
And the local also becomes 4 now, right? Because the start
Local
window
is
becomes 4.
local, right?
Because
And
you
compress it to 4.
window.
Sorry?
So you actually basically ditch the previous window and restart it like you did it last time.
Directly
Okay.
shift your
Going
left
to
to
ditch
right.
it completely?
Yeah,
So
you
you
should.
start at 4 now, right?
Sorry, I didn't get. Sonia, what were you saying?
The pointer at
So-
1, whenever you see your maximum, no, directly shift it to the wherever your right pointer is.
But are
Rather
we
than,
missing this window, like -3, -4? Are we not missing that window?
but that will again decrease your value, right?
Because 4 is the better thing from previous
Yeah.
one. So starting anything from 4 will give you better results.
Yeah, I think we
Right.
can reset our start pointer to 4 now actually, because we have
now.
already considered adding 4 to the previous element.
Okay. Whenever we
Start
do that-
index should be turned into end index pointer.
Sorry guys, I think somebody should do it. It's like
Oh,
Okay.
I-
So in your case,
Or you can share the screen directly rather than, going
Yeah.
to Starbucks.
I can show you. I have a whiteboard.
But I think the gist is like this.
Yeah.
So basically,
now you're
we'll keep on doing that,
Right.
and
exactly.
it will give the best
And
done.
yeah,
We have the
end index should be equal to start index.
Yes.
Okay. Whenever we find an index which is greater than the max, we change start and end index to that number and change the maximum to that number. Okay. And then start expanding. Okay. Now we start expanding the window, -1, and the local become -3, so we don't care.
No, local become 3.
Oh yeah,
minus
3. Yeah. 3. Local becomes 3, and the window is moved to -1, and then to 2. Local becomes 6, and max becomes 6. And we'll still continue to expand the window.
Hey, why don't we move the left pointer?
Sorry. Actually, it's not 6, right?
It is 6 now actually. After
5.
moving
It is
on.
5. It was 5 earlier.
No, sorry.
Yeah, it was 5 at index at value 2, but it's 6 at 1.
Yeah.
So, but when you increase the max, when you actually change the max because it was 5, so you, as per earlier logic, the start and it should again move to 2 position, correct?
Oh no, right? Whenever the index value itself is greater than the max, we do that.
Okay.
End index. So the value at end index, if that is greater than max, we are changing the start pointer to end pointer.
Yep.
You meant the current element.
Yeah, the current element.
Yeah.
Because that is logically the best thing to do at that point of time.
But before there was 3, right? And now become 5. So why don't we move the left pointer? Because it could potentially like remove the negative from the left pointer and make it bigger.
No, but we lose 4 then. 4 is a good candidate if it is in the window.
And
lose, how do we lose
it?
If we move the left, 4 will be gone, right?
Yeah, but 4 we already calculate the 4.
No, but
right?
4 and 2 can give me a better answer.
But when we at 4, we already recorded 4 as the max.
No, but if you see 4, 2, and 1, and -1 is the best answer here. If I lose 4, then I can't get it back.
Oh, we are not looking at single number, right? We are looking at the window.
Oh, look at the window. I thought that the answer is one single number, the largest sum.
No, the sub window.
Sub window.
Sub
Not the sub window, the sum, right? Look at example. The answer is 6. 6 is not like how big is a window. The sum, of that window, the answer is only a single number, right?
Yeah, yeah.
So,
Sum of sum.
The 4 which we got was based on one single. The window was only of size 1.
But in this case, we don't care about the window size. We care the largest sum.
Yes, agree. So
but we haven't finished traversing the array. So at this point, when we got 4, then we moved on to the next one. His window size is increasing. That time, when we continue to be at 4, and then this pointer moves to -1. At the time, the local is 3, and we already have 4, which is more, so we don't change anything, and we expand our window. At this point,
because I'm afraid, like, if the next number is negative, right, and then if we begin to contract, we will lose the biggest sum. So let's say if the next number is like a negative number, and now if we contract the number, then we may lose the largest sum there.
No, we will not lose. We have 2 trackers, local and max. Max will only change if you get a vector max.
So this max gets only overwritten when the local is more than this max. So when we are expanding the window at this point here, local is 3 and max 4. So we are not going to override it. We just increase it again, and so at this point, local becomes 5. So we change the max to 5. And we again move on. We expand this, and this becomes 6. So we'll override it. But now, at this point, when we expand it, we get -5. And local becomes 1. So we will not override max.
Because what I see is
at that moment, we should change our start pointer to the end pointer. So start pointer should be end pointer, and we gonna to start with -5 value. Penultimate index.
Your previous local is still 1. After that, if there could be a vector number, if I can add to a positive number, I can get a vector. But if I reset the window, I might lose that.
Yeah, what need to clarify, like when we at index at number 4, right? How do we know that at that number 4, the value number 4 right there, we have to move the left pointer? Why did we keep moving the right pointer? But when we have to move left pointer at that point. What decision make us do that?
So adding a previous local to the 4 was making the local low, and itself 4 was a vector guy.
Exactly. Yeah. So if this was like at this point, right, local was less than the number itself. So when we were traversing the array in the beginning, the local 1 -4, but the 4 number itself was bigger. So we reset the start pointer to 4. our start pointer will get reset when the individual number itself is greater than the local.
Okay, so when the numbers are greater than, okay.
So one question I have, Naga, so at that is one condition, and do we also have to see if the local is max?
We also have to see if local is greater than max. Yes, that's always there, right?
No, when we are resetting the start pointer.
When resetting the start pointer, oh yeah, we already know that that current element is greater than the local, so we don't have to.
No, but that could be max. So I think it's a safe check. Whenever you have a local, just check if it is greater than max and then set it to max.
Yeah, I mean, I didn't follow it completely, but the idea in sliding window, the one important condition is like, when do we start, until what condition you expand the window, on what condition you start moving from the start pointer, on what condition you change the start pointer. These are the two important conditions, right? So for us, what we said here is like, we'll start expanding the end pointer until we find a number which is greater than the maximum number. So that was one. And one condition to move the start pointer was, whenever the element itself is greater than the max, we said we'll move the start pointer to the end pointer. So that's the
Yes.
only condition I got.
Condition we found while running the example.
Yep. That's what I found. Yeah, that's what we saw. We were completely convinced that that would work.
Basically, Naga, we are trying towards pushing you towards that algorithm. So basically, the algorithm says that the one which the other person told, like cadence.
The cadence.
Got it.
Okay.
So basically, that. So I think here the trick is because that trick where your current number itself is greater than your than your local, then reset your window.
Okay. Oh, that's the cadence algorithm. How is it pronounced? Cadence?
I think so. Caden,
I think.
Caden or whatever. I don't know.
Okay. Yeah, I think every one of us will pronounce it differently. Okay. Should we try coding it up?
Sure. You want to do it?
Yeah, I can do it. Let me share my screen. That way, I think it's better.
So I'll stop sharing.
Yeah. How do I get this window away? What is the problem number, Sonia? Oops. What's the problem number?
It's a 53.
53.
Okay.
Now I just sent you the link.
Oh, okay. I think I got it now. So I'll say like max is equal to int underscore int max is equal to underscore me, and let's say for int I is equal to 0, this would be my let's say int start is equal to 0. So I'm still going by that window approach, if we go by coordinates, I don't think we need 2 pointers, right? Or we'd still need 2 pointers.
No, single pointer is enough.
Single pointer is enough.
Yeah, you won't, but I think you still have the gist of what you are saying, having, tracking to local and local and global sum. I think you're still doing what that approach says.
Okay. So do you want me to continue with this 2 pointers and optimize it to 1 pointer, or like, how do you want me to proceed?
We'll see, let's go with this, what you are comfortable with, and then we can see how it goes.
So what I would do here is, if so whenever I get the local, I'll update
Check
the
the
max
max,
here.
maxim.
Yeah, max is equal to max of comma. Sorry, maybe I don't know if this max and max will work. So
Let's go.
yeah.
You're also going to need to reset your local in each iteration.
And not reset, right? I would have to subtract the, whenever I move the start pointer, I would subtract it. I would reset it only when the value. So the way I'm thinking is, so if nums dot I, the value itself is actually greater than the max.
Okay, I see what you're doing.
Yeah, I mean,
max
I'm still thinking in terms of this the sliding window thing. So I'm sure we can optimize it. So whenever this is true, then what we are saying is like start is equal to end, and then probably here we say like local sum would just become whatever the value of that array, right?
Nums of I.
Yeah, nums of I. Okay.
So if condition is, you need to make it like max subarray.
Oh, yeah.
Yeah, and then we need to update the max subarray too. Right now, max subarray will be num i's.
Yeah, everything is like that's the max. Okay, that's true. Yeah, I see a lot of optimizations that we can do already. So,
but we have already updated it on the 12th line.
This actually would have made, if you take this example, some. I think this would not update the max subarray. It would have updated it with a subarray at that point of time, right? Which may not be accurate. So, like the case we were looking at, right? So when I'm here, when my window was like this with these two numbers, the subarray size is -1. So this would be updated to -1 here. right?
Okay.
Unless you do
Okay.
this, it would still be that. Okay, so this should do, right? And I think I'm missing the condition where if subarray is int minimum,
Naga, can I suggest something?
sure.
I think you got it, like the condition, like in the if you just check, if you like how you're doing the check for max subarray, like if it's greater than, you are updating only if local is greater than n. If you check, do similar check for local,
Mhm.
that if local is greater than number, maybe then you would not need the condition.
Oh, you mean I would not need this condition here?
Yeah, I think so. Because if you think about it, where you are updating the local is when the local is less than the number itself, right?
And the local is less. Yeah, and thinking the condition is where so I'm thinking the condition where we don't even update the max subarray at all. But I don't know. There's nothing like that, right? When the array size is 0, then we return int underscore minimum. And when the array size is 1, we update the local and we also update the max subarray. So I think I'll need this condition only in the case where the array size is 0. In that case, if the expectation is to return int minimum, that is okay, but I don't think they gave anything here. Given an
So if you have local as minimum and max subarray as 0, if your initialization is reverse, right? Max subarray versus.
So if max subarray is 0,
Yeah, and int
then we'll
and
lose
local is int min.
then we'll lose the 0. I think. Yeah, should we run with this example and see like the corner case?
Sure.
If this will
Absolutely.
work, and then we can optimize the way you guys were suggesting, right? So right now my
where we are using this variable start, like we just initializing.
you're right. Start is equal to.
But what we are doing with start?
Yeah, we
Right.
know.
We didn't change anything with it.
It should be equal to start.
I think the loop should start from that point, I guess, right? End int end equal to start.
Yeah, the idea was to
make start to end.
I think the start will be used if they ask the sub array, but if it's asking for the sum, maybe it's not needed.
Yeah.
Okay. So what we thought was like when we get here, right? We wanted to start calculating the subarray from here again. But in our case, end is already there. So there is no point of, there's nothing like we have to, if we just reset the local, that is good enough.
I think the local and the sum, max sum is taking care of it.
Yep. So we don't really need that. I think we are right. So what we have to do is just reset the local is what we need.
Yeah, and I think that's what Asim was pointing, like this will eventually become like with one pointer itself we can do this, I guess. No, we don't need like.
Yeah, that's exactly the question, right? Why do we need it? We don't need it.
Yeah, I mean, but it's a good discussion, like why it's not needed. So we are coming to that point, I guess.
Yeah. And again, I think like I don't have to set the local to this value, right? And once we set the max to max subarray to the nums of I.
No, you need to. Otherwise, at the start of the loop, you are adding the new number to the local, right? So it will keep adding. It will become like a total sum, right? You need to reset the sum to the maximum value.
The local we are accumulating in
we
local.
have to have that local. Because in line 19, we are continue to add the next element to it, right? In our example, after 4, we added -1 to it and 2 to it. So
That's true. Okay, sorry guys. Okay. That sounds right so far. What do you guys think? Should I run this example?
You are using that I, you need to change that I to end in nums, line 19, 21 and 23.
Right.
19.
Yeah, I would fail terribly in the interview.
No, that's okay.
Yep, okay. Should I run the example, run the code itself? Looks good for me actually.
Run the code, I think.
Run the code?
Yeah.
No need example. Okay. Yep. Wow. Okay. Let's try to run this example and see what went wrong. Do you guys see anything obvious that I missed here, or shall I debug through the code?
So one thing is that we are increasing
in order. Yeah.
So local, we are setting it to the nums current number only if the current number is greater than maximum subarray.
Yeah.
Okay. I think. Sorry.
Yes, go ahead.
I think the number 20 should come after number 25. Line 20 should come after line 25, because so what we are doing is we are getting the max of local and subarray, and then again we are checking with the max sum with nums of end. So nums of end will be already part of the local, right?
Yeah, makes sense, right? We change the max sum. But why would it make a difference?
So my thing is that if you're changing the local at line 23, then there is no effect of it whatsoever, because in the next execution, you are going to change it to plus.
No, we are adding a number to it.
Oh, I see. Okay, makes sense. Makes sense. Okay.
Wait.
The other suggestion, like putting it here was as 20, 25. What difference would it make?
See, line 24, why are you actually overwriting maximum subarray?
Yeah.
So
because you are actually, whatever maximum you got till that point, you might even make it lesser, right?
No, right? For example, the earlier, so if you take this example here on the left, so we have this window. So the local sum is -2, 1, which is -1, right? So the
okay, yeah, I got it.
But we can do that at the moment when we are putting that in a local only, at the starting only. We can compare that when we are adding that to our current local, or is that making a maximum, or the element only is making a maximum?
So you mean to say check the condition even before doing the local sum?
Yeah, so in
No.
the yes,
How then?
because we have to take the maximum of so when we are adding to the our current element to our local and or the current element which is there, because either -2 is maximum, -2 plus 1 is maximum, or only 1 is maximum.
Yeah. Hey, shall we do something like this? Like what we thought about the logic using this example, right? And that worked. And when we
Yeah.
took this example, it failed. So
Yeah, we should
run
run
this
through that
example
example.
and see like what is the condition that we missed.
Yeah, perfect.
Yeah. So let's take this one. So our start is 0, local is 0, and the max was int minimum, right? And now I changed, my window is 0, 8. So I changed the max, and actually this is interesting. So now the max is 8 at this line, at line 20, local is 8 and max is 8. And my number is not greater than, the number 8 is not greater than max. So I come out, and then now I expand the window. The end is actually 1, right? So end is 1, and now the local sum became minus 18, sorry, minus 11, right? And I see that the max is the max. So I don't change anything to the max sum, and I don't enter the condition because minus 19 is definitely less than 8, right? So now I go end is equal to 2. So this, now my window is this one. So minus 11 plus 5 would be 6, right? Minus 6, right? So and again, max sum, local is minus 6, max is 8. So no change to the max sum. It doesn't go into the if condition because 5 is less than 8. So now end is incremented to.
But we see something is wrong there already, right? Because we should have moved the beginning pointer to 5.
Yeah,
No,
exactly.
no, right? Only if max is greater, if the value is greater than the max. So the value is,
because we already recorded the max is 8, and
yeah.
now we see 5, right? And when we have to move the right pointer to 5, we start the right pointer there, because now we know between 8 and 5, 8 already the max, and we already record the max. That was, at the beginning, I was asking why didn't we move the right pointer? I mean, why didn't we move the left pointer at that time, right?
That's when. So the condition that we thought we would move the left pointer to right is only when the value at this end is actually greater than the max, which is 8.
But the local sum at that point is smaller, right? Yeah, it's smaller, right?
It is smaller. So
yeah, and then the value at that point, it's a positive. So we have to begin a new window there.
Oh, okay. So should that be the condition?
Yeah, we are not sure that the where we are starting, that is the, we should start from there only.
So in this case, we don't have 2 pointer. That means local is taking care of the other pointer or other window, right?
Yeah.
Now, what does local means? Local is
there is no start. Okay.
Count till I.
Count till I, right?
Yeah.
And when we have to reset the local?
Whenever you find the element at current index is greater than your local sum.
Greater than count sum till now?
Greater than max sum.
Greater than max sum, that, okay, let's see if that is the correct. I thought if local is the count till I, then we have to change I whenever we find that count till I is, less than my current element, or count till I minus 1 is less than, but let's see. how it works, whatever you are thinking right now.
I think at line number 20, so instead of max average, it should be local. Line number 19 should come after the if block.
Okay, yes, that is
and line number 23 should not be there.
Okay, let's see what we're doing here. But I think, okay, maybe we are moving that direction, but let's continue with the thought process here. Go ahead.
Go ahead with the example and see what I kind of see, like somebody suggesting like how we should use local instead of max summary to check this condition.
Yeah, so in what scenario that line number 20 will satisfy? When your local is negative, right?
When my local is negative,
or the previous value for the negative previous value for the local was negative, then only in that case it will be less than num ends, right?
It will be less than the max, and this negative value is greater than what is max, right?
So line number 20 is little bit dicey here to me. Why? Because we are saying that when my current number is greater than the maximum I have seen so far, then only I will reset my pointer, or then only I will reset that, right? Is it correct condition?
Yeah, that's the assumption we made with this example.
Okay.
And that kind of work, but yeah, is that the right condition?
Now you're using only one pointer.
There's no there's no pointer. So basically that's why I was asking again, what is the definition of local? Local is the maximum so far at the point I.
Yeah.
And then we are resetting it at some condition, right? At what condition we want to reset local?
On a condition where the value at that pointer is greater than max.
Max so far.
Max so far.
So we are saying that, okay, go ahead with that, okay.
I think another condition we need to put a line 20 as like if the nums n is a positive and max sub array is negative, then we have to update the local, right? Because if the max sub array is negative, then we know that we have to start the local again. Does it make sense? Because we only look if the nums n is bigger than max sub array, and in this case, max sub array is always negative. In this case, it's negative, right? So we don't update the local here.
That's possible.
So okay, let's look at this point right now. We know that the current value is 5, right? It's positive, and the max sub array is negative.
No, the max sub array is 8 actually. At this point.
No, when we point to 5.
Yeah, when we point to 5. Yeah.
Oh, okay. It's 8.
When you point to 5, max array will be 8, but your local will be negative, right?
Yeah, local is -6.
Yeah.
In that case, you will have to reset local too.
Yeah.
Oh, in that case also you are saying we have to reset local. That we are not doing this case.
Yeah. That's why I think you, instead of max array, you should check your local.
Yeah, in 20 line, the if should compare with the nums and to the local. And if you move the line 19 after the if condition, it works.
Now take it after the if block.
Yeah, because you take the local first and then keep track of the maximum sum.
Okay, so now I think local also can be written like line number 24, because what we are actually doing is that local is either current number or max of current number or max of current number plus the sum so far, right?
You mean to say written local also would work?
No, I'm saying that line number 18. So line number 18 to 23 can be written as a line number 24. Basically,
Okay,
what we are doing.
As a single statement.
As a single line.
Oh, as a single statement.
Local is equal to max of current number or the last local plus current number, right? That is what essentially we are doing.
Yes.
Yeah. Yeah.
Local is equal to if local is
Max
equal
less
to
than
No, just
Local
take
equal to
max
max of. Equal to
Max of that.
nums
Local.
and
sorry.
Local
nums
plus.
and. Yeah. The current number is nums and.
You can do either ways.
Okay. Num.
Yeah.
And
Plus local.
And the second is that local plus nums and.
Yeah, both are, yeah. Anyway, it's fine. So essentially that is what we are doing. See, line number 18, we are saying that local is equal to local plus nums and then 19 to 23, we are saying that, oh, if my nums and is greater than local, then I'm gonna reset what I did on line number 18. So exactly line number 24 is doing essentially same thing now.
Okay.
Okay.
Looks good.
This is what he boiled to Kadane's algorithm.
Yeah, exactly. This is actually Kadan's algorithm.
There is no two-pointer approach then. Single
sorry,
pointer.
guys.
Exactly.
Yeah.
Sorry, guys. Okay, long about, I think.
Yeah, I doubt it is marked as easy question. I mean, unless you know this algorithm or you have done this before, it's little difficult to come up with,
No, whenever I see subarray, I kind of think like, oh, they're talking about a window, so I try to apply that the sliding window algorithm. So, but yeah, this is a good learning, good optimization, I think.
This is actually a sliding window.
No, but two pointer we are not using. No, simple pointer only.
So, I think
still looking at the window, but typical sliding windows are usually 2 pointers.
Yeah, exactly.
Yeah. So here, if you have to return that subarray, then you will have to use
maintain the pointer,
2 pointer. But here, because we are returning only the sum, so that's why we are not using.
Or you can think local as the left pointer.
Local as the left pointer.
You still have to maintain
pointer sum.
So you still have to maintain the sum. But I'm saying that so the thing is that what if you have to return that pointer saying return the start and range. You still have to maintain the local, but with that you have to maintain the 2 pointer, right?
Right. If you have to maintain
if you have to return, yeah.
I thought this is the most optimized solution, but it's still like only 20% of overall C++ solutions, it seems.
No, that's a relative comparison. The others have submitted.
So it's not really only 20%. Okay. Okay, good to know. Because I see this as like very optimized way, but yeah.
Kadanes is basically dynamic programming only, no? Like you have choices and.
Yeah, or either we can take one array which is having the DP.
Exactly.
Dynamic program.
It's a DP.
Taking a number which is previous. Yeah.
It's a dynamic. Okay. Yeah, I never thought it in that way. Okay. Okay. Good, guys. Should we move on to the next? Sonia, you.
Yes, please.
Yeah.
Cool. Good. Thanks, guys. I'll stop sharing.
Chaitanya, did you have some other approach, or this is the one that you also have?
This is the final one, I think, Kadanes.
Yeah.
Others we have like we can create all the sub arrays and get the maximum out of it, which will be like order of n cube. Generate all the possible sub arrays. Yeah.
N square, right?
N square for generating sub arrays, and then you need to find the maximum out of that. Now, which sub array is giving you the maximum sum? So order of n for that.
No, that is still n square, right? Going through it one more time, n times.
So for every sub array, you will go for n check, which is maximum, right? So n square sub arrays will be there, and every sub arrays you will iterate at least once to get the maximum, to update the maximum sum. No. So it should be.
I thought we'll calculate the sum as we are looking at the subarray. So
it should then. I think.
Okay. Yeah. I mean, yeah. I'll look into it again. But yeah.
Okay.
Well, yep. Cool. Sonia, all yours.
Can someone show me what is the solution that we got?
Oh, okay. I can put in the chat.
Okay, thank you.
Sonali, was that the solution you had also?
Yeah. If that's the same, then it's in the solutions, I believe. Oh. Yeah,
Sonali, are you there?
Yeah.
We lost her.
No, I still see online. You're on mute, I think.
She's on mute.
Yeah, Sonali is on mute. And Sonali?
I think she's trying to speak, but it's it's not audible. Yeah.
Sorry. Can you guys hear me?
Yeah.
Okay.
Now.
And I'm sharing. Give me 1 second. Am I sharing the right?
There's no sharing it, I guess.
Give me 1 second. So yeah, the second question. Yeah, Bhavish, I had the same solution as Naga came up with.
Okay. That's nice. Thanks.
I didn't come up, but yeah.
So for this second one, it's 2D matrix, and we need to rotate this image by 90 degrees in place. And last year when I was interviewing, I came across this or very similar. I mean, every interview I attended. So anybody want to talk about the approach?
So I was thinking like to taking a transpose and then like taking a transpose of a matrix and then just reverse each row till the middle, like because transpose is making horizontal to vertical or vertical to horizontal.
Mm-hmm.
And then once we get that, the only work left is just reverse those columns for each row. Like here we have like if we reverse, if we make a transpose of this matrix, which we have 1, 2, 3, 4, 5, 6, 7, 8, 9. After the vertical, we'll be having 1, 2, 3 in a vertical line, 4, 5, 6 in a vertical, and 7, 8, 9 in a vertical. I'm assuming that because we are having always be n by n, so we don't need an. So there is, we can do it we don't need an extra memory to do that. So once we get that, so as you can see, the answer is after the 7, 8, 9, and 1, 2, 3 are exchanged, then we get an answer.
Okay.
Can you do how to do the transpose or traverse?
Just like reverse the ij to ji.
Diagonal.
Yeah.
Yeah.
So what are gonna look like ij and ji on the diagonal line?
So, when we are starting a loop, so our j would be always be like 1 plus 1 plus 1 ahead of the row. Where is our rows? So for example, if I can explain
you want to share your screen, Sonia, and try?
Yeah, I can share my screen. Just give me a second.
Sure. So meanwhile, like when Sonia is taking time, does anybody have any other approach besides what Sonia mentioned?
Yeah, I think I have a similar approach, but it's the way it's the different way of doing. Maybe we can discuss after Sonia is done explaining the approach.
Sounds good.
Maybe I can also just draw and show.
You can replace this corner
Sonali,
elements in a circular way. Like you store your first one and then replace 1 by 7 and 7 by 9 and 9 by 3. So
Yeah,
outer root.
exactly. I think I was also telling the same approach where you pick up the 4 corners first and replace them, and then move your pointer to the
4268.
yeah 4268, and then you shrink towards the inner of the array basically. So
every time.
once you do that rotation or the transfer, then you go to 5.
Okay. So basically the layer method, like
Yeah.
outer layer, that is
yeah,
1, 2, 3, 6, 9, 7, 8, 4. That's the outer layer. Then you come to the
it will solve the outer layer first and then come to the inner layer. Like in example 2, it will solve 5, 1, 9, 11, 10, 7, 16, that layer, and then it will shrink within the array to 4, 8, 3, 6, 4, 8, 6, 3.
Yeah, I tried it, but it's hard to keep track of I and j where it end up to.
Yeah.
So I'm ready to share the screen. So
Maybe I can that Leon, I think after Sonia is done, I can just explain a little bit if that helps. That particular method.
So I was thinking like it's hash, I mean, but sorry. So something like, for example, we have 1, 2, and 3, and here is 6. Let's take these two first. So we know that this is when we interchange these two, which is 2 and 4, what we need is this 2 is on the index of 2 is 0 and 1, and 4 is at 1 and 0. So similarly, if when we are moving ahead, and now here comes our third row, which is 7, 8, and 9. So when we are moving ahead, which is our next is 3. So our 3 is at 0 and 2. And if we exchange, if we exchange this rows and columns, which is 2 and 0, we'll be getting this 7. So my approach is to exchange these numbers by making rows into columns and columns into rows. So this is one algorithm. I'm not sure what the name of it is, but to make it a transpose, we can do this. One approach is this. So after this, when we done with this, our metrics will be look like. Once again. Our metrics will be like 1, 4, 7, then here is 2, 5, 8, and next is 3, 6, 9. And so now, if you can see, our answer is just we should reverse only the first column and the last column, and then we can achieve that answer, which is
which is equal to reversing all the row like in a single array.
so yeah, for each row we need to reverse those like column. Are you able to get that approach?
Transpose the matrix and reverse each array, each
row.
Each row.
And the main part is we can optimize it. Like we don't need to go till the end to reverse it. We just need to go to the middle of it, because we know it's a n by n matrix, and we need to go till the middle of because how we can optimize the reverse of an array.
Yeah.
There is a problem like how to reverse an array. So we can reverse the array just to going to the middle of it, middle of the row.
Mm-hmm.
And that's an optimization.
Could you quickly go over the for loop, how you do for the transpose?
Can I go and code it for?
Yeah, I think just do for loop right here and see how it.
Oh, okay. So for example, so now I am in a Python. So it that would be like my. I'll be taking the length of. So my for loop would be like, it should be in range. Column would be like i+1 to n, which is when my row is 0, my column should be 1 + 1 ahead. Because that's saving the point where we are at that moment. For example, 0, 0. Because if I can start from there, but it should be like it is replacing 1 at that 1 only, which is not we want, right? So at that point, so we are just moving ahead to replace those values which are like which are ahead of them. For example, here is 2 and 4, and next we move is 3. So when we are at when we reach at second row 4, 5, 6, 4, then here also 4 will be like our column would be 1 ahead, which is so because here after moving over, so after the first ith row will be 0, and then after that we'll be having we'll be on row 1, and at that point our column is here this and i+1, which is j. One second, j is, for example, I is 1, then our j is 1 + 1, which is start from 2 till n.
So do you have a swap condition here, Sonia? Like you have to have the swap, right?
Yeah, we need to swap.
Yeah,
We need to swap these.
Swap is what
so in Python it would be like, I'll just write it down. ij, let it be full H.
Sonia, do you want to code it? And then after that, we can quickly check with Sumit what he has to share.
Okay, yeah, sure. I'll just
So
code
we don't
it
have
now.
much time for the third question then.
Yeah, got it. So this is the for loop for transposing it. And for reversing it, I just need to go to each row and in each row, I have to go to n by 2 because I need to go to the half of my columns to make it reverse. And here also, column with here the reverse should be like I'm on each at that particular row, so that should be length of which is n minus j minus 1 and then matrix. This is just a reversing thing.
Each row, yeah.
Be able to get this condition, like why I did this?
Yeah, you're going to the end. Every time you're going to the end and end minus 1, right? You're swapping with first and last. It's as good as you're maintaining 2 pointers, first and last.
Yeah, exactly. As good as I'm explaining, I'm doing the 2 pointer, but here it should be like because as I am moving, I don't know how much I have to. For example, in this 4x4, I have to making a 2 iterations for j column wise to make it like I and j to be like move at the center. So with this, if my j is increased, but here it would be like at the second last point. For example, my n is here is 4 and my j is 1. So I'll be at the 4 minus 1, which is 3 minus 1 at 2, which is at the last.
You still need I over there, right?
Sorry?
You still need
Oh, yeah, I sorry. I missed.
And the next line as well.
Oh, yeah. Okay, shall I run this? I think I need to make it in.
There's no multi-line comment in.
It's not coming over here.
Okay.
Shall I submit it? We just need to check one exit condition. If matrix is equal to null. Base case is always.
Both are same only, right? Matrix none or length of matrix 0.
So, so here is like sometimes in Python is there can be empty array is sometimes there comes up, so that's just a one condition to be checked first. Yeah, that can be one thing. We don't need that condition, but in some questions when I do that, there is a requirement of so I'm assuming like if my matrix having row but not column, so that's one thing.
Yeah, in case if you're trying to access second row or something.
Yeah, to make sure that it should not be there. So yeah, this is the question. Can we move forward? Do you want me to explain more or like?
I think Sumit had another idea on like how he wants to solve.
And Loin has some question about it.
No, I understand it. That's good. Thank you.
Okay. Okay. stop sharing and Sumit, can you explain?
Yeah, I mean, so should I explain like the other way where we go circular and then try to shrink within the array and swap elements?
Sure.
Or because, okay.
So Sumit, you basically have like a start and end, and then you kind of move
Yeah,
the
exactly.
pointer.
Exactly. That's
Yeah.
what my approach is actually.
Yeah, that's exactly how I did. And the only one of the things what I thought like with this approach, like there's a lot of very similar problems for 2D arrays. Like you you write it in the circular, you go walk through and print it out in the circular fashion, or you have zeros. If one of the rows or the columns at 0, you mark it at 0. So one thing what I found helpful with that approach is what you're just going to discuss is that having those clear understanding how we move around with those pointers, it helped me with solving those questions too.
Okay. Yeah, yeah. So which was the problem in lead code? Just let me find it. Just
it's in the handout.
Can you see my screen?
Yeah.
Yeah. Yeah, so basically the approach is as somebody mentioned, and that's the same approach what Sonali is also talking. So suppose I take this example, right? And so I'll try to explain the approach and also write maybe a pseudo code so that it can fit in. Okay, so so as Sonali mentioned that rotating through the index I and j, right? So I'll just, for this approach, it makes really easy if we have the index handy, just to visualize the solution. So if you see here, what I'm doing is I'm just writing the index everywhere in this solution. Just a minute. Yeah, and then also I'll do the same thing here. It will move my so basically the approach is what we are doing is just a minute. So what we are trying to do here is we are taking the outer layer of this 2D array, and then we are replacing one, I mean, either way, either we want to do it clockwise or anti-clockwise. So if you want to do clockwise, then we replace 3 with 1, right? And 3 moves in place of 9, and 7 moves in place of 1. And once we are done with that, then we go to 2, 6, 8, and 4. So we move 2 to 6, 6 to 8, 8 to 4, and 4 to 2. Okay. And does anyone have any question in this one? Like the approach, what I'm trying to say?
Can you repeat one more time? First one.
Yeah, so basically what we are trying to do is we are trying to swap all the elements in the outer layer. So basically what we are, as a part of that, what we are trying to do is we are trying to pick one element, like suppose we are picking 0, 0 element, right? So we move that element in the position of 3, and 3 moves to 9, 9 moves to 7, and 7 moves to 1. Okay. And then, yeah, go ahead. Somebody was saying something.
No, as I think so. Yeah, the easiest understanding is, suppose what if we have to move just 4 corner, right? How we can do that, and then expand it to then inner element also on the same line.
Yeah, exactly. Thanks, Bhavesh. Yeah. So once we swap all these 4 elements, then we have to swap on the same layer. We have to swap the remaining elements. So we will have a loop which will go to the next element and then keep swapping 2 to 6. 2 will be moved in place of 6. 6 will move in place of 8 and like this, right? And once we are done swapping that layer as well, then we shrink our swapping to the next layer, which is 5 here, because it's the matrix of size 3, right? So if suppose it's a bigger matrix, which is right here, right? So it will swap this outer layer, which is 5, 1, 9, 11, that layer, and then it will move to 4, 8, and 3, 6, this layer. Does that make sense?
Yeah.
Sumit, can you explain that rotation with the second example?
Yeah, when you have,
Yeah, sure.
yeah.
So, okay. Yeah. So again, I
Can I
mean,
suggest one thing? It would maybe helpful if you use the pointer names like start, end.
yeah, definitely. Before that, I wanted to make sure that we understand this swapping with the index. So basically, I can do that as well. Um, so suppose again I write this 0, 1, and this is just for the understanding. Okay, the index, right? So we swap 5, and when we say, so I think swap is not the right word actually. So what we are doing is we are replacing 11 with 5, okay, and we are keeping 5 in a temporary variable, and then 11 will go here, 16 will go to 15, and 15 will go to 5. Okay, so suppose there is a loop on I which is equal to 0, right? So the next time when the loop goes, it will go for I plus 1, which will be this element at position 0, 1. And then what it will do is it will move 1 to this place, 10. And 10 will be moved to 12, and 12 will be moved to 13, and 13 will be moved to 1.
No, 12 will be moved to 2. I guess. Oh, 13, yes.
Yeah. So I think if I explain a little bit, as I think Sonali was saying, that maybe
so essentially it is a swap only, but it is a swap between 4 variable, right? If let's say that there are 4 variable and we want to swap V1 to V2, V2 to V3, V3 to V4, and V4 to V1.
Right.
Now, basically we have to keep changing the position of all these V1, V2, V3, V4. So first V1 is, at 5, V2 is at 11, V3 is at 16, and V4 as 50. Now we change that to V1 as 1 in the first row, something like that.
Yes, exactly. So just to explain, so somebody asked about this with a bigger matrix, right? Does that make sense?
Yeah, and again, when you go to inner matrix, it's you only did the outer circle, right?
Yeah, so we did an outer circle, and then as Sonali was saying that we will have 2 pointer, right? The start and the end. So start will be 0 and end will be pointing here, okay, at 3. Okay. So once we are done with one circle, what we will do is we will just increment our start. I'm just writing a pseudo code which we can use in our code as well. Sorry, and minus. So what will happen is the start will point to 1 and end will point to 2, right? Does that make sense?
Yeah.
I mean, there's more code to come here, but what I'm trying to say is 1 and 2. That means I'm at 4, 8, and 3, 6. But there will be a variable which will drive that you will be at this line 15, and then there'll be a variable which will drive that end, and then you point to this variable.
And the question is always n by n matrix.
So what will be the start and end value when you're moving from 1 to 10th place, 1 and 10, replacing 1 and 10? 1 will go to 10, 10 will go to 12, 12 will go to 13, right? Here.
Oh, no. This start and end is just to, basically in which ring we are.
Okay.
So basically we are in outer ring, where the outer ring start with the 0 and end at n minus 1. When we move the inner ring, that is 4, 8, 3, 6. So that time start is a 1 and end is n minus 1. In this case, it will become 2. So then we are looking at the inner square. And basically, if there's a bigger matrix, we kind of move ring by ring by ring, and from out we start and then keep coming inside.
Yeah.
And then within the ring, there is a code to move whatever Sumit was talking about, basically swapping the element. That will come now.
Yep. And then we just go from start to end. That's our condition as usual, like if we are traversing through the 2D matrix. And then, so this is the logic which I was more interested, like I think what Leon was saying. So what will happen now is that, as I said, right, it will cover this outer layer, but at the same time, it is covering 2 row and 2 column. If we see this circle, right, I mean, not the circle exactly, but this layer, the outer layer, once we are done with this, before incrementing start and end, incrementing and decrementing, it will totally, I think somebody has to mute, somebody's typing, I guess. So it will take care of rotating this outer layer completely. And that in turn will cover your 2 columns and 2 layers, right? 2 columns and 2 rows. Does that make sense? Like this row and this column and this column, and this row and this row will be rotated, right? So
0 and n-1 column, 0 and n-1 row.
Yes. Yes. And I think it will be within while loop. So now comes the rotation part, like how we do the rotation, right? So in order to do the rotation, what we do is we start with 0, 0, 0 index, right? And our start and end is something which we are driving from the outer loop, like where our start is. The start is right here, right? My start is right here and end is right here, right? So the inner loop, what I will be running, what that will drive, I'm taking an I as a variable. So what that will drive is, so if we visualize this, if I do whatever the start is and then plus I position, right? I get this element actually. What I meant by that is, let me write this and then hopefully it will be more clear. So what I'm trying to do here is, whatever is my first element, I take a backup of that. So the way I take the backup is based on this I, because this is my variable which is driving this rotation. Like first it swap in one execution, first execution of for loop, it will swap 5, 11, I mean it will rotate 5, 11, 16 and 15. But this I will drive that where my next rotation should start. So I, when it becomes 1, then it comes to this element, and then it tries to rotate this one, where it will rotate with 1, 10, 12 and 13. Okay. So let me write a little bit of code, so I think it will make more sense. So, and that will give some visualization. So basically what I'm doing right now is I'm taking a backup of my first element, which is at 5, right? And it is just a simple rotation, where since I have taken a backup of this guy, the first element, so what I have to do is I have to replace something here, right? In place of 5, I have to get 15, right? So what I'm going to do is, so now we'll need this pointer, like here, if you see 0, 1, 2, 3. So basically what we want to do is, we want to bring 15 in place of 5. And this should be linked with our I, basically, because the next time it has to go to 1 and it has to go to 13. Okay. So let's focus on just 2 elements. 15 should go in place of 5 and 13 should go in place of 1, right? So what I'm saying is, I need to have at this place, I need to have 15 now, right? But how do I make it or write the code in a way that the next time when I becomes 1, so this is being taken care, like 13 goes to 1 and 1 goes to 10, right? And that's where your start and end comes into the picture, that in order to, because I'm doing start plus I, because next time when I becomes 1, I get to 1, right? And end is nothing but 3 for me here. So I have to do end minus I. So that's how I can reach to 2. Does that make sense? Like the first loop, I is 0, so it will not affect. The 15 is what we are going to get. But next time when I becomes 1, we get to 13. When I becomes 2, we get to 2. So the way to put this is like I'll do and minus I. That's how I'm going to build this actually. Does that make sense? I'm using multiple. Does this make sense or it's confusing?
Yeah, yes, it's good.
Yeah, and the next time again, so if you see the pattern here, what we are doing is whatever is the right side, we are trying to, I mean, it's a simple, like we are swapping kind of a thing, right? Like we are taking a backup of the first element and we are trying to fill in this element. So we don't have to really remember this thing, but it's more of a logical way that what should vary, right? And then that's how I change my pointer. So next time I have to set this element like n minus I and then start, right? And the next time what should happen? Can somebody help me? Like who is new to this approach? So basically what I can help a little bit. So what we have to do is like 16 needs to move to 15, but the thing to keep in mind is 16 is at end, right? And 16 position is 3, right? So next time 6, so basically how I can access this element is end comma end, right? This is my last element of the matrix. But from 3 I have to move to 2. So basically the row remains 3, but the column keeps on changing.
N minus.
Sorry?
N comma n minus I.
Yes, exactly. Does this make sense? I don't know who said that, but I hope it's not the same person who gave the approach previously. Is it making sense? I don't know.
I think
Yeah,
so.
yeah,
You're explaining pretty well.
yeah.
Sorry?
Yes, it makes sense. You're explaining very well.
Oh, okay. Yeah, I mean, people who don't know this approach or seeing this approach for the first time, it will be good. Like if you have. So again, what I will do is I'll do the same thing, and if somebody can help me, like again, right? So what I'm doing is I am at start and end. This is my start and end position, right? Because this is 0 and 3 position for this 11, right? But eventually what will happen is I access 11 and move it to 16. But next time, the end 3 will become 2, right?
No, n minus 1. No.
Oh, sorry, 3 remains the same. Like the end remains the same.
Start will become, yeah,
Column, the start
Yeah.
changes.
start will become, yeah.
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 Can somebody help me? Like, what will be my next condition here? Like
Start plus I.
Start plus 1 I. Sorry.
yes,
Huh?
exactly. Start plus I. Basically, what I'm doing is I just take start and end, and then I keep on adding my I, which is my variable here. So 0, 1. So next time it will become 1 row and the third column. Then it will become second row and the third column. Right? And at the end, we have taken a backup of temp. So this is very simple. Like what will go at 11, right? 11 is like whatever we have taken a backup. So it will be right here. That's it. This is my code actually. We can try running it and see if it works. So any questions?
I think so.
No,
We have to add the layer part, right?
Sorry?
the while condition is doing that
Yeah,
layer.
right. While is the but
Yeah, so the while condition, as we are
yes,
saying, right, that as I mentioned that it's solving two columns and two rows at once, right?
yeah.
So we start with start and we go to end, right? So in one loop, it is swapping 5, 11, 16, 15. But as this loop finishes, all this outer layer will be rotated, right? So the start has to point here, come here to this row, and end has to come here. So that's why we are incrementing start and decrementing end.
You can go half of the row till, I mean.
So yeah. Basically, in one pass, you are like taking care of two rows and two columns. Like
Yeah,
for
yeah.
example, you're taking care of half of the array once this complete for loop runs.
Sumit, the line 29, the I should start at start the value of I, or because if we are always starting with 0, that means we are not going in inner loop, right? The for loop I.
Yeah, but
he has to pick that 5 also now. Keep
no,
that variable.
what's happening is that start next time is start, right? Like when you come to 4, start is at 1.
Start is as 1, but if you see the line number 29.
29, okay.
The I is always 0.
Yes.
In the Bhavesh,
okay.
index is
I got it.
start already. Yeah.
Because that's where what we'll do is we'll pick 4 and we'll add I to it, which is 0. So this will give me this position itself for now.
I think never mind. I got it. I think it was my mistake. So we are doing inside start plus I, so that's fine.
Yeah, exactly.
Yeah. It is fine.
Yeah. So I think I think we can run this code, or I think we are already out of time. Sonali, do you want to? I can send this code in the Slack channel, or because we already run one approach. Sonia already did that, so
yeah, sounds good. This will be
but
perfect.
any question you have in this one, because after I learned this approach, I felt really good actually about this 2D. As I think Sonali mentioned that approaching these kind of problems like spiral matrix printing and all, it made me think differently and really helped.
It's a very generic way, like CTC I also have mentioned there.
Yeah,
any
exactly.
spiral problem. Yeah.
So I think only one thing with this approach is that we have to make sure that it's always n by n matrix. This will only work for n by n matrix, right?
Yeah, definitely. I mean,
And
otherwise.
so if we have, I'm not sure if has anybody ever come across with that we had to do something similar where the matrix is n by m.
I don't think rotation will be possible.
So if you get n by m matrix and you have to rotate, then you can't do in place. Basically,
symmetry will be lost. Yeah.
Symmetry will be lost. So you have to define a new array.
Yes.
So m by n, you have to convert n by m, and if you are doing that, then it is just problem of copying over how you want to copy.
Yeah,
That's right.
Right?
You want to in place, so that will.
Yes, that's how once I've got tricked. So let's move on to the third question.
Sure.
Yeah. Okay. I'll be discussing third question. So we are already 2 hours away, but I guess it is fine, right? If we take another some time to discuss that.
Can you copy this chart window for now?
Yeah.
Say that again, please.
Yeah, I will share the code in channel itself, or I can put it there. Yeah, you can take the control. I don't know, to stop sharing.
Yeah, that's fine. Okay, I'll start sharing.
Yeah.
So Sonia, is there anything else to discuss about this, or I can move to third problem?
No, I think we are all set with this one.
Yeah.
You take over for the third one.
Okay. All right. Okay. So the third problem is this one, where we are finding the largest rectangle in histogram, right? And the idea is, it is, I think, the similar problem of histogram where, we have given an array. Basically, this array represents the height, at that index. So let's say that this is 0 index, 1, 2, 3, 4, and 5, right? And the height is given. And what we have to find out is that the rectangle that can fit who has a maximum area within this view. So there can be many rectangle, right? One can be with this rectangle, right? All one height, that rectangle, and the area of that rectangle would be basically 7 into 1, right? 6, 1, 2, 3, 4. Yeah, good. Thanks.
Yeah. Yeah.
So second is, it can be at 2, right?
Yeah.
So that area would be 2 into 4, that is 8. Or there can be another one, just this height, right? 6. That is 6 into 1, right? That is area is 6. But the correct answer in this case is the one is this is shown, right? 5 into 2. So basically that is total area 10. And that is what we want to find. What is the maximum area you can get with given histogram? Maximum rectangle area. Okay. Everybody's clear about the problem?
Yeah.
Okay. So let's start discussing. Anybody want any thought about it? How we can solve this?
I mean, as long as you find that your next rectangle's height is greater than previous one, the chances of getting the area will be larger. So you keep on stacking all those on your array. The moment you find that the next histogram height is less than your top of the stack, so now you start calculating the area till the point you reach where you find a histogram height less than your current one.
Okay. I think
explain with the diagram. Yeah, that will.
Yeah, you are directly talking about, yes, the solution. Yes. Let me give some thought before we reach to that, and then probably if someone has any different thought, they can share. Okay. So let's take this 2, right? So this 2, right? So this 2, the area of this 2, basically the rectangle is, the next element is 1, right? So we can't go any further. So if we want to make a rectangle of height 2, then one rectangle is this we can make, right? Basically, if you want to make a rectangle at this point, right, at 0 index, we can only make this one, right? If you want to make a rectangle at 1, right, we can make really big rectangle, right? And that would be this whole rectangle. So how we define how far I can go left and right, right? So basically, we can go as far as we don't find anything that is less than the current value, right?
Right.
For example, for 1, we can go left as far as I don't find anything that is 0. And same thing on the right side, I can keep going as far as I can find, 0. If I extend that to this index of 0, 1, 2, 3, 4th index, right, at this 2 here. So I can go left as far as I don't find anything less than 1, right? So that is here. Till here I can go. And on the right side, I can go as far as I don't find anything that is less than 2. So that is actually end of the array. So that is how we can, if you want to apply brute force method, basically at every point I can see left and right and figure out the index, how far I can go on left and right side, and then basically calculate that area. Right? So at every point I will keep doing that. So I will do at 2, I find the answer, that is for 2, the answer would be 2. At the 1, answer would be, it will start from here and here. So answer at 1, answer would be 6. At 5, the answer would be basically 10. It will be this 2 area, right? So 10. For 6, answer would be just 6. For 2, answer would be 8. Basically, I can go from here to here. So 2 answer will be 8. And for 3, answer would be 3. And then I basically find whichever is the maximum, I will return that. So that is brute force. I think it is how far it goes. So it will be n square, right? Because at every point I have to scan the whole array. Right? So far it is clear, right? How we are solving it. Does anyone have any other approach? I think we already discussed one approach. That might be the final approach.
So is it like instead of finding it every point, should we come to the maximum number from the left and try that instead?
So let's try it. So maximum number from the left, right?
Yeah.
So yeah. Sorry, go ahead.
And also from the right, I believe.
Okay. So from both sides, maximum left and right, right?
Yeah.
Okay. So we want a maximum number or its index?
Maximum number, maximum
okay.
maximum height. I mean.
So maximum number on the left side. Suppose we are calculating for this point, right? At 2. So maximum number on the left is 6.
Yep.
And the maximum number on the right is 3. Right?
I meant like maximum height from the left and maximum height from the right.
Okay. So at this point, what would it be at this point at 2?
In this case, I mean to say in the complete array, you start from the start from the, if you are starting from the left in the complete array, you go to a point where you see the peak.
Okay, so we see peak at 6.
Yeah.
But we don't know till we reach 3.
Right.
So we're saying that scan the whole array, and I found that the max is 6 and minimum is 1.
Yeah.
Right.
Just finding the peak window. Yep.
Then what?
Yeah. I thought just looking at this example, I thought like you come from the left and you see the maximum value is 5, and you come from the right, you see maximum value is 6.
Yeah.
And then yeah.
So we can't just find the maximum of the whole array, right? If we want to do that, I think we use that approach in where we have to find how much water it can contain when it rains. That city lines problem, I think.
Yeah. I think I'm into that problem.
So there we basically, but there also we find, so far I have seen on the left side and so far I have seen on the right side, things like that, right? But so we have to find at each point something. And that is a efficient way to find it, inefficient way to find it. But yes, we have to calculate at each point, saying that at this point, what is max so far on the left side, what is max so far on the right side. So in this case also, we are doing same thing as I explained. At each point, basically, we find what is how far I can go before I find the minimum. And in the right side also, I'm doing the same thing basically at each point. And basically now so that is definitely one solution, but that is n square, right? N square solution. And we want to see if we can, further optimize it. Yeah. Okay. So I don't know who talked about this thing, right? That increasing element. So that is kind of a solution for this. And since we have a little less time, we'll directly jump to that. Okay. So what happens? So at 2, right? If let's start with the beginning, right? So at 2, I go next. My next element is 1, right? So do you think I'm able to ever gonna expand this 2 further than where it is right now?
No.
I cannot, right?
Yeah.
So basically what I'm saying is that whatever I can achieve with the current element 2, I have to calculate now. And I'm not gonna, in future, never I'm gonna include this in any calculation, right? So So basically, I'm done with 2, and I'll calculate saying that, okay, the area is 2, right? Now comes the next element, that is 1. Okay, so yes, 1, I saw that. So now next next element of 1 is 5. So I know that 5 is more than 1. So I keep going, right? I can basically expand in that direction, right? Then 6 is also more than 1, right? Now 2 is less than 1. Oh, sorry, more than. So okay, so I think I say different way. So we are done with the 2. Now we are starting with the 1. So we are saying that 5 is more than 1. So now I'm here. Now I'm saying that 6 is more than 1. So now I'm here. Now I found that 2 is less than 6. Sorry, 6 is more than 5. So I was going there. 6. Now I find 2, and 2 is less than 6. So I know that 6 cannot go any further. Is that correct?
Yeah.
So I need to figure out. So I can't go further. So I have to see in the back how far 6 can go, right? So that we can find basically how much rectangle we can make. And we know that the last element we saw, that is 5. That is not good for 6. So the 6 is the only element that can fill the rectangle. And basically then we take the 6 out of calculation, saying that now 6 is never gonna come. But I still have a 1 and 5 in my calculation.
So had there been 2 towers of height 6, we could have gone for 2, right? 5.
Yes.
Yeah.
Yeah. Yes. We will cover that also. Yes. So there are suppose another 6 we can calculate 6, 12. Yeah. Right. So now I have 1 and 5, and the next element is 2. Now 5 is also, the 2 is also less than 5. So that means now 5 also cannot go further, right? 5 went, 5 expanded here, but now the next element is 2. So 2 is not going to support 5. So we have to basically say that I'm dropping my calculation for 5. Let me figure out how far I can go. And since my current index is at 2, I say that, oh, I can go up to 2. And if I see the reverse, my last element before 5, the element is 1. So I cannot go that side also, left side also. So this is how far I can expand 5. Okay. Now let's put that in some with some data sets, right? So in this example, basically we are using a stack, and we are using monotonic increasing stack, right? So what does it mean is that all the element I want to put in a stack, as long as they are in increasing order. Okay. The moment I find the element that goes into stack that is decreasing, I have to do something with the stack, right? So okay. So in this stacks, right? First I'm starting with the position, right? 0 position. 0, 1, 2, 3, 4, 5. So in the beginning, right, there's nothing in the stack, so I'm just putting in the stack. But to make it simple, I'm just putting -1. That basically indicate my end of stack. Okay. So otherwise, I have to make a complex coding where I have to say that if stack is empty, do something. If stack is not empty, do something, right? So in this case, my whole calculation is stack is never empty, right? And the last index, basically this 0 index, and before that, whatever it is, I'm just calling it -1. Okay. So I put -1, then I am starting to iterate through all the elements that we got, right? 0, 1, 2, 3, 4, 5. So my next element is 2, right? And basically my next element is 2 that I'm going to put in stack. Okay.
So you're putting
because
the index or the number itself.
Why? Okay, when I put in the stack, I put in the stack when my if the top of the stack is -1, that means my stack is empty, right? Or the last element that I put in the stack is less than my current element, less than the one that I'm doing, then I will put in the stack. Okay. So my condition is if stack dot pop is equal to -1, right? Or the another thing is that the last element, so last element or stack dot pop only, right? All the top. So basically this is the, we are putting index in that, right? So
yeah.
So value of stack dot top, not pop. That's correct. Yeah. Is basically as long as it is less than the current value, I'm gonna put into stack dot push. So 2, I got 2 and stack is empty, so I just put 2 in the stack, right? So basically I am putting index, okay? But too easy to understand, that's why I'm showing value. So -1, we are assuming that its value is 0. Here it is value is 2, okay?
Where is the current?
Yeah. Say that again.
I don't see the current.
You don't see current.
You wrote if stack.pop is equals to -1 or value on the stack top is less than current. So that current is variable.
So current is
0.
So value at the current. So we are starting. So now we are iterating through our array, right? So current is basically the element that we are looking at. So right now we are looking at this.
Is this the index? Current
Index, yes.
or 2?
Yeah. So let me.
Current is the value, right?
We should check for value, right?
Yeah,
We
exactly.
are taking the value and pushing the index.
Yeah. So value of current index. Okay. So when we are doing that, basically my current index was 0, and I was checking condition if the value of stack dot pop is -1, or if the value of the stack dot. So basically, in the beginning, I'm just going to hit this condition, right? I don't need to do anything. This one. So I'm gonna just simply put 2 inside the stack. Is that okay? 0 and value. Okay. Now I'm moving from 2 to 1, right? Next index. So 0 to 1. So now I'm moving to 1. Now, if I say that stack dot pop equal to -1, it is not -1. It is actually 0. So it has some value, right? So let's check what value it is. The value at the top of the stack is 2, and the next value I'm getting, that is 1. And my second condition says that no, you can't put 1. I mean, so the next value you're going to put, that is less than what already there in the stack, right? So we are going to put 1 into the stack, but before that you want to do something. Because when we discussed, we said that whenever we are getting the next value that is less than the current value, now the current top of the stacks, basically 2, it is not gonna useful further. So I'm gonna remove the 2 from the stack, right? So I remove, basically pop out this 2 from the stack. Okay, so the popped out index is basically 0 index I popped out, right? Now, so we want to finish the calculation. How much, so what have we popped out, right? How much rectangle I can make with that popped out value, right? And the way to calculate that is basically, what are we popping out, right? So the it will be basically I minus stack dot peak, or I'm saying, but it is current index. current index minus stack.peak. So whatever is the last index I have in the stack, that is -1, right? Into the current height what I have. Okay, so current height is 2. So when I popped out 2, the current index, now we are at current index is 1, right? So current index is 1 minus stack.peak. So the last index in the stack is -1. Okay. Sorry, I have to do one more thing, -1 also, because it is a zero-based index, right? -1, right? Into 2. That is how big rectangle I can make with the 2. So the answer is 2. So far the max value we have seen is 2, right?
Yeah.
Could you please repeat why you did the -1?
Oh, okay. So if I don't do -1, that means, okay. So since the way we are calculating, right? What I'm saying is that when I pop out the 2, so that in whatever the index I popped out, right? That index was 1. 0. Sorry, it was 0 or 1?
0.
0, 0.
It was 0 on index. And okay. And then the last index that I'm popping out is -1, right? Sorry. Now the top index is -1, right?
Mm-hmm.
So this -1 is my arbitrary index. I put that extra element,
Mm-hmm.
right? So 2 can go how far in the left side?
0.
Nothing, right? If it is a -1, then it cannot go left side.
Right.
And the right side, it is going up to 1. So current index is 1. Now since our zero-based index is there, that's why I am doing -1, extra -1 here, just to compensate the zero-based index. Because the way I'm calculating how big rectangle I can make with the 2 is basically my next index minus my previous index into the height, current height.
Okay. Every rectangle, so you're making it that specific rectangle by subtracting the previous and the current.
Yeah. So previous index is this, right? So basically, so we have a 2-pointer, right? One is this that I'm getting from stack. Another one is this, that is the next one. So the way I'm calculating is basically whatever I came out.
Bhavesh, in this case, 0 minus 2.
No. I think it is this one you are telling, right? So
Yeah.
I think this is wrong. I need to take the current index, that is 1.
1, yeah.
Thanks for pointing out. As I said, I'm going to take current index, not what is coming out. So coming out, I will just take to figure out this value. What value I need to multiply with. Understand? No. Let me repeat that.
I'm still confused.
Okay, that's fine. Not a problem.
I think next iteration will get better.
Yeah. But yeah, let's repeat one more time this one. Okay.
So I'm still confused to why we take a stack of indexes instead of values.
Why we take stack of index instead of value, right? Let's take both and let's see what happens. Okay. Basically, the value can be repeat, right?
Right.
Index
right.
cannot repeat.
Yeah.
So to figure out those things, if we take the stack of value, then it will be very difficult to figure out. So what if I have a 2, 5, 5 and 2, 6, 6 as we discussed?
And secondly,
I mean, it is not there in this sector.
For calculating the width also, you need index, not the height. So we are putting index inside the stack.
Yeah.
If you are at 6 height, then your till that point your width is 3. That is the current index, whatever you are. And minus, you do up to 2 index, 3 minus 2 and plus 1. So that will give you the 1. What do you say? The width of 6. Current index minus the 1 index back, a minus 1. I mean, since it's starting from 0.
But if you compare the current value with the like topmost stack value, then that should be fine, right? That should take care. Like you should push only if it is in the increasing order or something like that, right?
That's true. But how will you calculate the width then? Basically, that inserting index helps you in calculating the width, because when you pop out, you use the current index, right?
Yeah.
Yes, that because otherwise you could have pushed that value directly also, height also inside the stack.
So indeed, because based on the index, basically we can, yes, that is true. Based on the index, we are going to figure out what is the area, right? So basically, there is a max area that I will take as a 0 or int mean, right? Whatever. And then I am running the for loop. For int I equal to 0, I less than my length, whatever is given, I plus plus, right? Now, what I'm seeing in this loop, right? So, you know, basically for this I to push, right? Basically, I'm seeing that right now I'm writing if, but I'm going to change, right? If stack dot peak is not equal to -1, right? And the heights of stack dot peak, so the last element that is there inside, that is not -1, and the height is if it is greater and equal to the current heights that I'm getting, right? Current size that I'm getting that is greater or equal, then I have to do something. I can't just simply push it, right? So I have to basically keep popping till this condition is satisfied. So instead of if, I'm going to do a while. Right. So, and when I basically pop, so in this case, when I was at the 1, right, in the 1, and I pop, I got whatever the index I got, that is the index I popped is basically it is the standard thing. Basically, we are maintaining a local global max, right? Or the value that I'm popping is basically right. So that is whatever I'm popping from the stacks and the value at that index into I minus so whatever is the last index -1. Does it make sense till now?
Yeah.
So does anyone have a doubt about this, how we are calculating using index? Now if we satisfy the condition where we say that the next element, so there is no more element that is bigger than the one that I'm putting into the stack, then I'm gonna basically do the stack dot push. Okay. Okay. I. So when we move from 0 to index 1, I put 1 index. Its value is 1 basically, right? Now we are moving further. I'm moving to index 2. Its value is 5. Why I'm putting in stack? Because if you see the stack dot peak is not -1, but the height, whatever height we have at the peak is it the correct thing? Peak is greater or equal to the height I. It is not -1, and heights at the peak is greater or equal to height I. Yeah. Right. So we are not satisfying this condition also, right? So we are not going in while loop basically, and we are directly going this stack dot push. So 2 goes inside, right? Now 3 goes inside that way. The value is 6. Now comes the 4. Now the I is 4. Correct? When the I is 4, we see that the next element that we are going to put, So this condition doesn't satisfy for the I is equal to 4, right? So the stack dot peak, at the peak we have value 6, but the new value that we are going to insert, that is value 4. So 6 is not gonna needed further, right? That's why we want that's at this point we went into the while loop and we basically try to calculate the area, max area, till we get, so basically how much element we have to pop till we get all the bigger than the next element. So now we are going at index I equal to 4, we are going to push value 2, right? So anything that is greater than the 2 need to come out of the stack. Okay, and that's why this while loop is there, and this condition basically take care of anything that is greater than 2 will, till that time the while loop will run, and whatever comes out we kind of calculate the area using index. So in this case the first index that will come out is index 3 and its value is 6, right? And let's calculate this area. Max area is equal to the current max is, till now current max is we have so far is 2, right? And then we keep adding 1, 5 and 6. Now height of stack dot pop, that is 6 into I. What is my current I? 4 minus stack dot peak. So after removing 6 from the stack, what will remain in the stack? Stack dot peak.
2. No. Current max is
2. Yeah, it's 2. Yeah.
2, right? I mean, we remove the 6, right? We basically pop it.
Yeah.
Then whatever is remaining in the stack is 2, right? This index of 5 minus 2 minus 1 minus 1, right? So that is the, so whatever element we picked out, index 3. So what rectangle we can achieve with that 6 is value 6, and we will replace our current max with that 6, right?
Yeah.
Now once we popped out 6, now we again in the while loop where we are seeking that I'm going to insert value 2, and I'm seeing, but my stack still contain the value 5. Basically we have an index, but based on this condition, the last value we have in the stack is 5. So we need to pop out 5 also, because 5 also cannot go further, right? So we pop out 5. Now based on this, let's calculate when we pop out the 5, what is the rectangle we can make with the 5. So height of stack pop is 5 into I is still 4 minus, once we pop out 5, what is my index? 1 plus 1, right?
Minus.
No, minus 1.
Yeah.
So that is basically 10, and we are saying that this is my current max now. So essentially what we're doing, see, we want to maintain the monotonic increasing stack, right? So when we had a 1 and then we had a 2 and then we had a 6, the moment, we had a 5 and 6, right? The moment we got saying that I'm going to insert 2 to keep the stack in monotonic increasing order, I have to remove anything that is less than 6, right? So I removed, less than 2. So I removed 6, I removed 5 from the stack. So now if I insert the 2 in the stack, it is going to be monotonic. And the moment I remove the 6 and 5, we are going to calculate how far, what kind of big rectangle we get, right? So see, 5 was there in the stack because 6 was supporting 5, right? The moment we got 2, what the top value is 6, it is not supported by 2, so we removed 6. And then we are checking the next value that we are going to insert 2 with the, what is the top value in the 5. Now 5 is also not supported by the 2. So we removed 5 as well. And the way we calculate the area is basically the whatever the index before 5, right? And whatever the current index I am. And basically the difference between that two index and then current value is my area.
No,
Okay.
makes sense.
Does it make sense till now? I think there are a lot of silence, so probably there are some doubt we
No,
can discuss.
it makes sense.
It makes sense. Yeah.
I think we have to do dry run once by ourselves
Okay.
and more.
Okay. So we keep doing this, right? So now we have 1 and 2 in the stack, right? 1 and 2, the value I'm talking, but if you see actual value in the stack, that would be index 1, 1. And now we put the index 4, its value is 2 in the stack, right?
Yeah.
Now the next value is 3, and that is increasing. So we can still put 3 in the stack, right? Oh, sorry, that will be the 5 because it is still increasing, right? So if you see our stack value is still, I mean, the value of stack is still monotonic, 0, 1, 2, 3. It is always increasing. As long as it is increasing, we can keep putting because we are gonna keep supporting those values. Okay. So now we are out of this while loop and a for loop. So at the end, once we are out of this for loop and while loop, basically we have to empty the stack again, right? Because we have to calculate those values. Right? And that is again simple, same calculation what we are doing here. You know what we are doing here, and we can again run the while loop till the stack is empty. So while stack dot peak is not equal to -1 because we inserted -1, right, in the beginning. So again, max area I'm calculating equal to max of current max area or whatever I'm peaking, right? So the whatever coming out of stack is height of stack dot pop. I'm just popping into. Now what would be here? Previously there was I. If you see here, what would be here?
The index of the last element in the stack, I think.
Yeah. So, but this was previously it was I. So index of the next element we were doing, right, in calculation. So basically, we were running this while loop when the next element is bigger than current element. Now in this case, the next, so we reach the out of our array. I mean, we reach at the end of our array.
Yep.
So that is again the another thing, that is 6, right? We have to consider.
Oh. Okay.
Now, so in this case, we just consider the length of the array. Height dot length. Okay. Minus stack dot pop, stack dot peak actually, and -1. So it is the same formula what we had before, just that instead of I we are using N because that is what our I would be when we come out of that loop, right?
So Bhavesh, this is calculating the area of the rectangle that is starting from the height 1 till
no
3, right? It is supposed to, because
yeah. So we'll go through this one by one, right? So because we have 4 value in the stack, 0, 1, 2, 3, right? 4 values in the stack, and their index is -1, 1, 4, and 5. Correct?
Right.
So first we will basically get this index 5 out of stack, right?
Right.
So index that we got out of stack is 5, and the value is 3 at that index. So this formula is basically whatever value we got out, that is 3 into whatever the height at this index, right? That is 3 into total length of the stack. So that is 6 minus, right? What is the previous index? we are doing stack.peak. So before we take out 3, what was the previous index? It was 4.
4.
Right? Because we are doing stack.peak -1. Correct?
Mm-hmm.
So that will be becomes 3 into 1. Right?
Mm-hmm.
So we got that answer. That is, so with the 3 we can make 3 height, right? Our current highest is still 10. Current highest is still 10, current max, but with the 3 we can make out this, right?
Mm-hmm.
Now we are done with the 3. So let's take the next index out. So next index would be, next index that we are taking out of stack is 4 and its value is 2, right?
Mm-hmm.
Now what we are doing? Now let's calculate this. So height at that index, that is 2 into length. So we are doing n. So n is in this case 6. Minus, once now we take out 4 and 2. So now 1 is there in the stack, right? -1 minus 1. Is that correct?
Mm-hmm.
So 2 into 4, that is 8. Right? So, so this is the crux of the algorithm. Basically, what we are doing, we are keeping the value in the stack that is going to be supported in till end, right?
Mm-hmm.
And we, whenever it is not supported, basically we are getting the less value, we are removing that. But see, while calculating, we are basically calculating that index plus where it started or the last index before that. And that's how we are basically making sure that when we calculate for the 2, the next, so we are ended at here, right? We ended at 6, our loop.
Mm-hmm.
So 2 is supported on the right side till 6, and on the left side till I remove what was the element before 2, because that was the less element, right? Last less element before 2. That index 1.
Mm-hmm.
So with these 2 index, basically we are calculating how big the rectangle can be.
Mm-hmm. Okay.
Yeah.
Makes sense. Yeah.
Okay. And basically every time we are keep calculating local global max, and that would be our answer.
Mm-hmm. Yeah.
Any doubt and question about this?
Somewhere I saw people are using divide and conquer, like dividing the array into 2 equal halves, getting the max.
Yes. I think there are kind of 3 or 4 approach for that. Okay, and LeetCode also discuss about it. So one is the brute force, right? What we discussed, and that is going to be n square, right? The other one is the divide and conquer, what you are telling. I haven't gone to detail, but that will give you the O and log n, O and log n in a base case, but it can be worst case again n square, because divide and conquer, it is again depending on what kind of value you have. If the divide and conquer will work when the numbers are not sorted. I mean, if you look at the detail of that approach, but I did not go into that approach. Okay.
Yeah.
And this is the best approach that we can get using stack, because that is ON complexity.
Yeah.
Yeah.
And it's much easier to understand also compared to the others.
Yeah, divide and conquer, I find personally a little hard to understand, but I think it is a good approach. It is good things to know, actually.
Mm-hmm.
Yeah. I mean, somebody can, think about divide and conquer in this kind of problem, where I never thought my mind across saying that I can solve using divide and conquer,
Mm-hmm.
I can think about n square solution easily. And after some study, I did not come up with this, but I also studied this, and I can come up with the ON. But divide and conquer, if even if somebody tells that, okay, use divide and conquer right now, for me it is a little bit difficult to come up with that right now.
Yep. This makes sense, actually. Yep.
Yeah. So the code is very simple. Basically, there are, I think we can do special session on the monotonic increasing stack because a lot of problem are there. Solve that can be solved using the same technique, monotonic increasing stack.
Bhavesh, actually, Roger had done this monotonic stacks session actually on couple of Sundays.
Oh, I see. Okay, maybe I have missed that in the beginning.
You have missed it, yeah.
Okay.
Yeah, there is.
Okay, that's good.
Yeah, someone shared it on this on the chat.
Yeah.
The,
So maybe there are, because there are many problems, so we can still do some more sessions because there are many complex problems also, which can be solved using monotonic stack. I think we should have one more session.
Okay. Yeah, but I think so if you use that, then only that complexity of this will come to ON. Otherwise, there is no other approach to solve it in ON.
Yep.
Cool. Yep.
Okay. Any question? Maybe I'll share the solution and go through it at once. It looks a little difficult, right? If you are still struggling with the pointers and other stuff. But I'll be happy to answer if anyone have any question. Otherwise, I'll stop at least recording now because it is a really long video.
Yeah,
we can oops. We can still discuss. I'm here around if you have to talk about anything.
Bhavesh, is there a good reference for monotonic stack?